Welcome! Today, we are diving into a programming puzzle that seems really tricky at first glance. But I promise you, the solution is so simple it almost feels like a magic trick. It all boils down to one single insight that just flips the whole problem on its head. So, this is really the question at the heart of it all. In programming, the first thing that comes to mind, the most obvious path, it's often a trap. We're not just looking for an answer here. We're on the hunt for that elegant, super efficient solution that just slices right through all the noise. And to find that beautiful solution, we've got to know the challenge inside and out. So first things first, let's lay out the rules of the game. Okay, here's the deal. We get a list of numbers. Our goal is to make its median, the number smack dab in the middle after you sort it, equal to some target number we'll call k. The only tool we have is something called an operation, which just means we can bump any number up or down by 1. And the objective, the real challenge, do it all in the fewest moves possible. Let's make this real with an example. So imagine our array is 2, 5, 6, 8, 5, and our target, k, is 4. First, we got to sort it, which gives us 2, 5, 5, 6, 8. The middle number, our median, is 5. Okay, that's too high. We need to get it down to 4. So let's try changing one of the 5s to a 4. That's one operation. Our array is now 2, 4, 5, 6, 8. But wait a second, the median is still 5, so we have to change the other 5 to a 4 as well. That's our second operation. The final array becomes 2, 4, 4, 6, 8. And look at that. The median is now 4. We did it. 2 operations total. So now that we've got the basics down, you might be thinking of a pretty straightforward way to solve this. But this is exactly where the puzzle lays its trap. I mean, the obvious thing to do seems to be just try stuff, right? We could start changing numbers randomly, check the median each time, and just keep track of whatever took the fewest steps. It sounds logical, but there is a massive catch. And here's that catch. The array we're dealing with could have up to 200,000 numbers in it. Trying every single combination on a list that huge, your computer would be working on it until the end of time. It's just not possible. This brute force method is a total dead end. We have to be way smarter. And this is what brings us to the best part of any puzzle, that breakthrough, that aha moment where everything suddenly clicks into place. This is the question that cracks the whole thing wide open. If messing with every number is a no-go, then we have to figure out which numbers are the only ones that matter. But which ones are they? The answer is kind of wild. It turns out that half of the array is completely useless to us. It doesn't matter at all. That is the entire secret. The second you realize which half of the numbers you can just totally ignore, the problem transforms from this impossible beast into something beautiful. This is it, the core insight right here. Think about it. If your median is too low and you need to raise it, why would you waste time in operations changing the little numbers way over on the left? They're never going to be the median. To raise that middle value, you only need to worry about the median itself and all the numbers to its right. And you guessed it, the opposite is true if the median is too high. You only touch the median and all the numbers to its left. The other half of the array? Totally irrelevant.
So we've got this incredible insight. It's pretty cool, right? Now let's see how we can turn this aha moment into a real, honest-to-goodness algorithm.
Step 1. This is non-negotiable. No matter what, you have to sort the array. This is the move that makes our entire strategy even possible. Seriously, this single step takes a random jumble of numbers and gives it structure. It gives us order. Without sorting, we can't even find the median, let alone figure out which half of the numbers we can safely ignore. All right, the list is sorted. Next up, we pinpoint our target. This little bit of code immediately finds the position, the index of our median. This gives us our anchor point, our North Star. Everything we do from this point forward is all based on this one single spot right in the middle. And now for the logic. Let's say our median is too low. We just apply our cool new insight. We start a loop right at the median's position and only move to the right through all the bigger numbers. For every single number in that right-hand half, we just calculate the cost, how many operations it'll take to pull it up to our target, k. Why? Because to guarantee our new median is k, every number from the middle to the end has to be at least k. We just add up that total cost, and that's it. That's the answer. So what if our median is too high? You know the drill. It's the exact same idea, just in reverse. We start at the median, and this time, we only move to the left through all the smaller numbers. This time, we figure out the cost to push each of those numbers down to our target k. To make sure that middle spot becomes k, every number in this half has to be, at most, k. We add up all those operations, and we have our minimum number. It's really that simple. So we did it. We've cracked the code. But what's the bigger lesson here? Let's zoom out for a second and look at the real takeaway. So what's the winning playbook here? It's 4 simple steps. 1. Sort the array to create order out of chaos. 2. Find that median. 3. Figure out if you need to go up or down. And 4. This is the real game changer. Only change the numbers on one side of that median. By doing that, we get to ignore half the data and turn a total nightmare of a problem into an elegant, super fast solution. And really, this idea of finding the hidden simplicity, it's not just for coding puzzles. It's a fundamental skill for solving any kind of problem. So the question I want to leave you with is this. What complex problem, maybe in your own work or life, could be totally transformed if you just found that one powerful, simple insight? Think about it.